All right, 8 o'clock. I see we've got a number of people already joined, so I think we'll go ahead and get started. Well, first off, hello everyone. Welcome and thank you for joining us today. My name is Amelia Martin and I'm an engineer in our Reston, Virginia office. I will be your MC for today's presentation. We are excited to welcome you to the 5th of 7 sessions in the series we're calling Kittelson Career Conversations. Whether this is your first webinar in the series or your 5th, we are so happy to have you here. Shannon, next slide, please. For those interested in our full series, we do have recordings available for our Career in Transportation, Kittelson Culture and Values, and Kittelson Internship Program presentations. Next slide. Yesterday, we heard from Lawrence and Segal about transportation planning projects, which is also available to watch on our website. If you have the opportunity to join us live for our last two, we'll hear from Radu Nan and Sarah Parks on transportation design projects Tuesday, November 17th. And lastly, we will be wrapping up the series with a discussion on research and innovation in the transportation profession on Wednesday, November 18th, with Gibran Hodge-Schick and Abby Morgan. At the end of this evening, we'll be sending out a follow-up email with today's recording and links to RSVP for the other sessions in our series, if that should interest you. All right, next slide. So today, our speakers are Jorge Barrios in our Orlando, Florida office and Shannon Workall in our Wilmington, North Carolina office. I can personally say you guys are in for a treat today. I've worked with both of them. They do really incredible work, have been super helpful for me on projects. So I'm really excited for you all to learn from them tonight. So with that, I'll throw it over to Shannon to unmute and give her quick intro and then over to Jorge.
Thanks, Amelia. Good evening, everyone. As Amelia said, my name is Shannon Workall. I'm a senior engineer with Kittelson. I've been with the firm for about a year and a half now. I am based out of the Wilmington, North Carolina office, but like a number of our Kittelson staff, I actually am a remote worker, even in non-pandemic times. I live with my family in Pittsburgh, Pennsylvania. My work here with Kittelson as an engineer mostly focuses in research in the area of operations, but a research focus, so helping shape national guidance and state guidance for various projects. I specialize specifically in intersections and alternative intersections, but I also do get my hands wet on some what I like to call real world projects in addition to my research work. So I'll toss it over to Jorge for his introduction.
Hello, everybody. This is Jorge Barrios. I've been with Kittelson for close to 9 years now, about half of that time from our Oakland, California office, but I am now speaking to you guys from Orlando, Florida. As with many other people here at Kittelson, I've gotten to work on a very wide range of projects, ranging from long-range transportation planning to kind of nuts and bolts traffic engineering and traffic operations. I also lead our firm's data analytics initiative, through which we're trying to infuse data analytics and data visualization into projects of all types. So with that, I will pass it back to Shannon to give us an introduction to traffic operations.
I will just say we have gotten some great questions already through the RSVP form, and we're excited to dive into those in our Q&A session. I do also welcome and encourage you to use the chat box in your GoToWebinar panel to post questions throughout the presentation. We will get to as many of those as we can at the end, so keep that in mind as Shannon and Jorge move through the presentation. So with that, I will pass it off to the two of them to show you some information on operations projects.
Thanks, Amelia. So we're going to have 4 sections to tonight's presentation. So we're going to touch really briefly on Kittelson's mission and values, then talk about what exactly is transportation operations. Jorge and I will both talk through a couple of projects that we've recently worked on. And then, as Amelia mentioned, we'll go into a discussion. So go ahead and send in those questions as we're talking, and she'll get those queued up for us at the end. So let's go ahead and jump into this first section here on who we are as a firm and what sets us apart. Kittelson's mission is to solve transportation problems to improve people's everyday lives. Transportation is what gets us from point A to point B, but it's also what connects us to all the goods and services we use. So everything you buy at the grocery store, every product you order online that comes through a FedEx truck or a UPS truck, an Amazon vehicle or postal service vehicle, every visit you make to office hours to see your advisor, to see your professor, simply transportation is the elements that keep us connected to our communities, to other people, and to the rest of the world. Our staff are spread out over 26 offices in 14 states. And one of the advantages of having offices around the country is that it gives all of the employees at Kittelson a chance to learn about how different organizations and governments operate. It also means that a lot of our offices are small to medium size. And as I mentioned, we do have staff that work remotely as well. Our largest office is in Portland, which is where we are headquartered. Even though we have employees across the country and a few remote employees that live in other parts of the world, we live out the mantra that we're one firm, many locations. And we do that by working in teams that are made up of employees from different offices, and we stay connected to each other in a variety of ways so that we're truly one firm in our approach to doing work and living out the Kittelson values. We have a number of core values. Just to briefly touch on two of them, we strive to have an outward focus, to focus on our clients, to focus on one another as the staff, to focus on our families, and to focus on our profession. And then we also very strongly believe in a trust-based environment. Oftentimes you'll hear Kittelson employees talk about being a trusted advisor to each other and to our clients. So diving in then to operations. Operations is the act of optimizing infrastructure to provide reliable transportation. And there's really 5 pieces to that. So the first piece to look at is looking at goals. So on a given project, the organization or government that you're working for likely has some sort of policies of the desired end state that they're working for. So maybe that's livability. Every community wants to make sure that they're a livable community. But for a specific project, you have the context that you're working in. So maybe you're working out in Portland. Portland's a rainy city. Rain causes delays. And so, the context of any project, operations project then, is knowing that there are going to be a good number of days where you're going to have some delays due to rain. On a project, you're going to have objectives as well. So those are the quantifiable results. What do we want to attain? So perhaps you're working on a freeway project, and we want to improve reliability. So it's good to have low delays, but really what people look for perhaps, or what the objective of the project is to make sure that when people go to leave for work, that they know that they can rely on the amount of time it takes them. They have a small range, maybe it's between 15 and 18 minutes door to door. We want that range to be as small as possible so they're not having to leave large amounts of time in case an incident arises or in case it's a rainy day. So they want to improve reliability. On this hypothetical freeway project, the strategy then to improving the reliability of the freeway may be something like ramp metering. So a strategy is a program of activities. So we may decide to move forward with ramp metering, where we try to meter the flow of traffic onto the freeway. And then specifically tactics are the specific methods that we're implementing. So in the context of ramp metering, that may be, say, releasing a vehicle every 3 seconds, or whenever there's a gap of a certain distance in the traffic. So working through those 5 key steps in operations projects. Oftentimes you'll hear in transportation kind of the four-step process of planning, design, operations, and maintenance. But we would put forward that operations is really weaved throughout all pieces of transportation. So when working with designers, If they would like to put in, a dual left turn lane, that may impact the type of signal timing that you can provide for that intersection. And so the design decisions have impacts on operations. And so the more that operations staff and design staff, maintenance staff and planning staff talk to each other from the beginning, the better integrated that process becomes, and everyone has an understanding of how their decisions impact the work of their colleagues. But operations is really about keeping buses running on time in the most literal of senses. So in that bottom right-hand corner there, we have our rainy freeway scenario that we just talked through. You can also think about operations on the corridor level. So in the top right, we have our corridor down in DC, where we're providing progression along the corridor. You can think of operations at the segment level, so looking at curb use with increased Ubers and Lyfts and robot deliveries, more Amazon packages being delivered, lots of people, goods, DoorDash. Lots of folks want to access the curb that didn't need to access the curb, and you still have everyone who has always wanted to access the curb, right? So the pedestrians are there, the bicyclists are there. So operations can look at how to manage that segment area. And then of course, there's also operations at the intersection level. Here on the top left, we have our transit system. So moving transit vehicles through the intersection, classic example of an operations project there. At Kittelson, our operations projects are really quite varied. So we work on access management, that would be along the corridor, looking at automated traffic signal performance measures. We talked about curb use and freeway management, also using new technologies and sometimes not so new technologies to work in the ITS world. And then signal timing and transit signal priority, as well as work zone management for work zones on the arterial or on the freeway. We work for a wide variety of clients in our operations practice. We have, of course, the local, regional, and state governments, but we also do work with developers and the private sector, and sometimes with other consulting firms who may be leading other parts of a project and will take the operations lead. So I'm going to toss it over to Jorge to talk through a recent project that he has worked on, the US 192 Mobility Corridor.
Yeah, thank you so much, Shannon, for your great background on operations. And you'll see that I'll be borrowing a lot from your 5-step framework as we move through this project example. Next slide, please. So starting at the very top with the goals. So this is a pretty challenging feasibility study that we supported the Florida Department of Transportation, FDOT, District 5 here in Central Florida over the past year and a half or so. As with many other regions in Florida, there's a lot of premium transit projects, ideas, studies that are kind of sitting on the shelf waiting for funding to be able to implement them and run them. And so FDOT was thinking outside the box and wondering whether they could offer some kind of premium travel option, for example, an arterial express lane on US 192 in kind of the southern part of the Orlando metropolitan area, and then use the revenue from that facility, from that express lane, to support bus rapid transit operations and being able to get those projects off the shelf and on the ground. So as with any other project, next slide, please. We started with setting the context. That's second step in Shannon's framework. As with many other operations projects, we will put together what we call the existing conditions report. We look at crashes, we look at traffic volumes, number of lanes, the intersection operations and delays, how much transit is there, what the ridership looks like. So that's all pretty common bread and butter stuff. And I didn't want to take a lot of time on it here. So I instead decided to highlight some of the more innovative existing conditions data sources and visualizations that we pulled in. So what you're seeing here is a dot density plot of trips being made to and from the corridor using a data set that we obtain from streetlight data. They collect just billions of cell phone location data points throughout the country, and we were able to tap into that to get a good sense of where the clusters of activity are on our 192 corridor. So 192 has a lot of destinations in these 20 odd miles that we were studying. Over on the west side, you can see the Disney, there's some theme parks there, some resorts as well. It's not where the core of Magic Kingdom is, but still a lot of Disney property pretty close to 192. And as you can imagine, there's a lot of hospitality and visitor retail on the corridor to support that. Fun fact, if you have seen a movie called The Florida Project, highly recommended, by the way, a lot of it takes place here on those visitor retail and hospitality sections that I've highlighted. And then as you go through toward the east, 192 goes right through the heart of downtown Kissimmee. So that's where you see a lot of work trips starting and ending. And there's also a small regional airport in that area. So with this data, we can really start to get a sense of those areas that we need to serve well with any kind of either transit or express lane service. Next slide. This data set is also useful in informing the length of trips that are happening on the corridor. So without cell phone location data, you'd be pretty stuck at what you see here on the top half of the screen, which is just basically daily traffic volumes through different points of that segment. It's valuable data, and you can look at it over the years and see where it's growing the most, where it's growing the least, sometimes going down. But for our specific purpose, trying to identify the potential for an express lane, we needed to know, how are people using this? Are they staying on this corridor long enough where that express lane starts to make sense? And what we found was that it is kind of barely so, but really only between downtown Kissimmee and the Disney area that we were pointing out in the previous slide. So we use this information to then trim our study corridor and really focus on this section with the most potential. Next slide. So here's basically that new segment from Disney over to downtown Kissimmee. Next slide. So we take that all in, and this is basically what we tell our project working group and our client. We're seeing a lot of scattered origin destination pairs, so not really any major predominant trip that, you know, if you put this ingress here at A and this egress here at B, you're gonna get a bunch of people. So that wasn't the case here. It really is pretty spread out. A lot of the trips are using 192 for short distances, hopping between some of the regional facilities, Turnpike, I-4, these are big interstates, big freeways. So there's only limited potential for those longer trips, and they really are between Disney and Kissimmee. And so we're coming out with the conclusion that your typical freeway express lane just wouldn't translate, wouldn't really serve the demand here. So we got to look at other strategies. And next slide. That is one of the other 5-step framework parts of that Shannon presented, strategies. We made a big list here of different strategies ranging from the very low cost, short time frame tactics that would look at modifying signal controllers, signal cabinets, just signal timing in general, to very high impact, high cost strategies involving grade separation, where you're trying to basically build a bridge over intersections. So with the help of the project working group, we really started to narrow down our options to something that's kind of in the middle, where it's not as low cost and short time frame as the signal work, but could actually get us a lot of benefits in kind of the mid-range. So we came down between queue jumps and a dedicated mobility lane. So that's what we were calling those, like an arterial express lane. But through some analysis, we realized with the queue jumps, you can get a lot of the benefits of that full continuous mobility lane without having to purchase right away throughout 20 plus miles. You can just focus that at the intersections. In case you haven't seen a queue jump before, we have a picture in the next slide. So it really is just a lane that is semi-exclusive or exclusive, generally to transit vehicles, where they can go and bypass a queue of cars waiting to go at a signal. So in this specific picture, this is from NACTO, you can see that little green ball signal head on the right. So that's giving the bus that head start to use that queue jump, get around the queue. And then after that bus is gone, the other cars will get their green indication and they can go. But then the bus has saved some pretty valuable seconds that can really add up over many intersections doing the route day in, day out. So we want to see how this could be extended to a combination of bus and tolled vehicles that could generate some of that revenue to pay for the bus operation. Next slide. So this is what we came up with. This is just a single intersection along 192. And we thought that we could add this managed queue jump. You can see there in the red, in between the right turn pockets that are generally there and the vehicular through lanes. So we're not converting any through lanes. This would be in addition to the through lanes that are already there. And our idea is that you could have a camera, so you can see it there on the bottom left, that could pick up any non-bus user and then build them accordingly with whatever the toll was at that time. Next slide. So one of the key questions that we had to work through our project was, okay, if you do this, how much travel time are people saving? Because we need to know that, because that's going to inform how much they would be willing to pay for using this queue jump, and ultimately how much revenue we could generate to pay for the transit service, which is kind of that goal. So here we're really diving into the tactics part that Shannon was explaining, really figuring out for this specific treatment, how would it work within the signal timing framework that's there already. So you can see here that we inserted that head start for that queue jump lane in the gray. The cars can use it, bypass the big queue building up on the general purpose lanes. The bus, which is that bigger pink rectangle, can also use it. And from this micro simulation, we're able to tell what the travel time savings is for those specific users versus what people on the regular lanes are experiencing. Our next slide will show a quick summary of what that came out to be. So for non-queue jump users that are stuck at the signal, they are experiencing a delay of about 89 seconds. But the ones that did use the queue jump, they saw only 71 seconds, so roughly an 18-second travel time savings. And as you know, we can convert time to money using value of time and figure out how that can build up toward paying for rapid transit operations on the corridor. Now, next slide. So as we wrap up the project, our feedback to our client is that there may be a potential here, but you need technology that is not either hasn't been invented yet or is not widely available. So basically, tolling through just cameras is not standard. The state of the practice now is using transponders, and that couldn't quite work here. So there's some technology barriers to doing something like this at the moment, but those barriers may be coming down in the next 5 to 10 years as these technologies become more accessible and cheaper. And so the idea would be maybe you can start with just a transit queue jump now, operated like other transit queue jumps everywhere else. But then as this technology becomes available, you can add that managed lane, managed queue jump component and start collecting some revenue. So with that, I will pass it over to Shannon.
Thanks. I'm going to walk through a recent project that we just completed on the research side of operations, and Jorge did a good example of explaining kind of the 5 steps of operations. I'm going to talk about that other piece that I mentioned at the beginning, which is how operations can be blended into planning and design and to maintenance. And so, Jorge talked about at one point they were evaluating alternatives. And so in the context of an intersection project, when you're on the boundary between you just about completed planning, you're starting to look into design, asking, okay, we need to improve this intersection, but what are we going to put there? How do we know what the best option is? Maybe it's dual left turn lanes. Maybe it's something like an alternative intersection, like an R-cut here on the top, a restricted crossing U-turn, or a quadrant roadway there on the bottom right. But when the question is, how do we know what the best option is? And there are methods that exist to help us analyze the value of different intersection designs for motor vehicles, but there wasn't really an existing methodology for evaluating pedestrians and bicycles in the context of these different alternatives. And we know that what gets measured matters. And so if we don't have a methodology to quantify the comfort and quality of service of an intersection for pedestrians and bicyclists, they just kind of get left out of this equation, and we end up selecting an intersection that works well for vehicles, but maybe is not preferable for pedestrians and bicycles. So how did we go about developing this method? Well, we came up with a number of sample designs, and we created two different means of gathering data. So first, we put together a web-based survey that was distributed nationally. We received over 8,000 comments where people were able to look at the sample designs and tell us what pieces they liked or did not like about certain designs. We then also traveled to 4 cities across the country to speak to groups of 5 to 8 people for 2 to 3 hours and really dig in on what were the key elements of the designs that they really enjoyed or really did not like. What was it about those designs that made them feel uncomfortable or feel unsafe? And then often in transportation, we have to rely as well on expert knowledge. So we had, it's just cost prohibitive to build 10 sample intersections. And so we have to use a number of different methods. And one of those is expert knowledge to understand what do we know about the data that tells us what's unsafe about a specific element of an intersection, for example. And so from there, we developed what we've lovingly called a game of 20 questions. So this is the methodology. It has some of these questions that we ask in the analysis or in the methodology address operations. Some of them are focused specifically on safety or comfort or quality of service. And then there are elements as well that focus on more design. So it's kind of that blend of where operations and design meet. So each one of these 20 categories here, you would evaluate for each pedestrian movement and each bicycle movement at the intersection. And so as an example of how you might do that, one question is motor vehicle right turns. So the question is, can a vehicle turn right at the same time that a pedestrian is walking? So here at this first conflict point, this would be in the scenario where right turn on red was permitted. So a vehicle headed westbound would be turning right on red. The north to south pedestrian would have the walk sign, so they would have the right of way. And typically we know that vehicles that are looking to turn right on red are looking to their left for a gap, and they often can miss pedestrians coming from the right. So there's a conflict point there. The second conflict point comes when vehicles are permitted to turn right at the same time that the adjacent pedestrians are moving. So here's our second conflict point. So the right turning vehicle would have a green ball, the pedestrians would have a walk sign, and sometimes we know at that conflict point, vehicles don't always see pedestrians. And so the analysis for this design flag or this question of the 20 questions is based on both volume and speed. So is the volume less than 50 vehicles per hour? Yes, if that's true, that's a yellow flag. If this conflict exists and we have low volumes, it's a yellow flag. If the speed of the turning vehicle is less than 20 miles per hour and we have this conflict, it's a yellow flag. If we say no to either one of them, so if we have a volume that's higher than 50 vehicles per hour, or if we have a speed that's higher than 20 miles per hour, then it's a red flag. And so red flags, if for anyone who's familiar with soccer, is a more severe concern than for this analysis. So you would complete this design flag questioning for each of your pedestrian movements, each of your bicycle movements, and then move on to the next design flag, the next question in our game of 20 questions. So you can imagine that we've done this for our 4 different alternatives, and we can consider then the percent of flags raised. So looking at alternative A, for instance, it has 81% of the questions did not result in a flag, 15% resulted in a red flag, and 4% resulted in a yellow flag, but is often the case in all areas of engineering and life in general. There's no straightforward answer. There's some engineering judgment that's needed here. So if you look at the top chart, the pedestrian assessment, you might be looking at alternative A versus alternative D, and you could ask yourself, well, alternative A only has 19% flags versus 23% flags with alternative D, but the bulk of those flags in alternative A are red, whereas alternative D, only 8% are red. So what's the value there? Do you want more overall flags but fewer red flags, or do you focus on the smallest total number of flags? You could also say, looking at alternative C for the pedestrian, we only have 15% flags, but alternative C for the bicycle, we have 37% flags. So where alternative C is great for pedestrians, it's not the best for bicycles. So this methodology is not perfect. Because there's no perfect intersection for all of our vehicles, our pedestrians, our bicyclists, our transit, considering all of the users, sometimes you're just in conflict. But we think this methodology is really helpful to help designers and planners as they're thinking through their alternatives to identify areas of concern, and it will allow them to consider pedestrians and bicycles when making their alternatives assessment. So with that, I'm going to send it back over to Amelia to head into the question and answers portion.
Great. Thank you, Shannon and Jorge, for giving that background and sharing some of your insights on projects that you've worked on. So as Shannon said, we'll go ahead and move into the open discussion. And of course, keep sending those questions in the chat box. I believe some have been answered with the questions. But we also had received some from the RSVP form, so I think I'll go ahead and start with a couple of those because I think Jorge's been able to answer some questions from people so far. All right, so the first one that I think we could go ahead and cover is how much freedom or influence do you have on what gets designed and built? How does your work impact what projects get built? And I think we'll have Shannon start on this one and then send it over to Jorge. I would just say for me, I have been able to experience seeing some projects I've worked on actually get built, which is really satisfying and very exciting for me professionally. So there is definite opportunity to see your operations work actually get put in the ground. But I'd love to hear from Shannon and Jorge some of your experiences with that.
Yeah, thanks, Amelia. So I'll speak a little bit from the research perspective in operations. A lot of my work goes towards getting other engineers to implement, for instance, this methodology that I talked about. So from the research side, there's a lot more freedom because research is just naturally, the clients tend to be less set in their ways of what they want as an end product. But I will go back in general on operations projects, as with many projects, there's a context that is predefined by the built environment, and there are goals that your client has. And so while we often try to present what we think is the preferred or ideal solution from our perspective, or the best alternative. It's not always the one size fits all. It doesn't work for all of the projects. So what you think is a great solution may not fit in the context of that project. But there is a lot. You are at the alternatives analysis level. You are making the selection of kind of which path to go down. And so from that perspective, you do have a lot of influence in what actually finally gets built.
So if I can add to that, I think, like I mentioned at the beginning, I've been lucky to work in a wide range of projects, from like early stage long range planning to very detailed traffic ops. And in my experience with long range planning, you can be super creative. There's tons of leeway for your recommendations. But to see that translate to projects on the ground could be a long time. I'm talking 15, 20 years. So that's kind of a drawback of that. On the other hand, in some of the kind of smaller traffic operations projects that I've done with smaller municipalities or counties, it's pretty common to see those go in the ground within just a few years, 2-3 years, and that can be pretty rewarding, as Amelia was saying.
Great, thank you both. Appreciate your insights on that. Next question I thought would be a good one to cover is, are CAV, so that's connected autonomous vehicles, CAV type projects becoming more common? What are the key elements in such projects from an operations perspective? I think this is a great question to cover because it's a really exciting and cutting edge topic in the field. So we'll go ahead and do Jorge and then Shannon on this one.
Yeah, so the short answer is yes, they're definitely becoming more common. I think within the past few years, we've gotten started on several CAV projects. They are mostly related to readiness. So a city, a county, an MPO will come to us and say, we need to have a plan for connected autonomous vehicles. They will be here in the future sometime. And we need to make sure that we're ready, that we've got the infrastructure that we need to make those successful. And that's where we come in. We have a lot of people with expertise in that area. In fact, I think we've got one webinar series on that with Abby and Jabran. And they can speak to it with much more knowledge than I can. But those have been one of the most common types of projects. I participated in a research project, I want to say about 6 or 7 years ago, where we were trying to find out how connected vehicles and the penetration of connected vehicles could influence strategies such as queue warning or variable speed limits on freeways, and whether that would be enough to squeeze out a little more capacity of an existing facility.
Yeah, and I didn't mention this in my introduction, but actually before I came to Kittelson, I took a sabbatical and worked for an autonomous vehicle company for 6 months. So I was working for Argo AI. For those who don't know, Pittsburgh is kind of an AV hub. So that was very interesting. My daily work involved reviewing data from the vehicles to see how they were operating on the streets. So a couple of thoughts there. As Jorge mentioned, a lot of the work currently is about readiness. So that's one aspect of that. May be, is our infrastructure ready? So a big area of operations obviously is signal work. Signals and the infrastructure that run signals tend to be in place for a number of decades, usually 2 or 3 decades. And so the questions right now in the operations world tend to center on what types of infrastructure do we need to start procuring and putting in the field right now, so that when connected vehicles come around in the future, our equipment is ready, because the equipment we put in the field today will likely still be there even if connected vehicles don't become super prevalent for another decade or 2. I'll also say one thing to keep in mind is that connected vehicles and autonomous vehicles often get grouped together, and we call them CAVs, connected and autonomous vehicles. But the technologies are really quite different and have significantly different impacts. And so when we look at the impacts of connected vehicles and the impacts of autonomous vehicles, it's usually in two different efforts. As Jorge mentioned, there was a research project he works on. I know a couple of other projects that are ongoing at the moment are trying to understand the impact of connected vehicles specifically on capacity on the freeway and capacity on the intersections, both for signalized intersections and for unsignalized intersections. But there's, as Jorge mentioned, there's a whole another webinar next week with Abby and Gibran, and so they can dive into those topics even more.
Great, thank you, Shannon and Jorge. I know that you both have good insight on that, so I did want to give you a shot at that. I had told people at the beginning of the webinar they would not be disappointed with your experience and the insight you can provide. And yeah, I think that's all great. It's always helpful for me to hear from other people at Kittelson in terms of what's going on and that edge of the field. On that note, I'm actually going to switch over to a question we got in the questions box because it's kind of related to project types with this topic that we're on. So somebody asked, are there projects that include citywide, within reason, operation management, or are the projects limited to corridors and intersections because of the multitude of data involved? Let's start with Shannon on this one, and then we'll go to Jorge.
Sure, yeah. So there are definitely projects that look at citywide operations or regional-based operations from the standpoint of what type of technology are you looking to implement. So a current project that I'm working on for Federal Highway Administration right now is helping them communicate different technologies that are available for work zone management in the area of ITS, so Intelligent Transportation Systems. So an example here would be if you're familiar with the zipper merge or the dynamic lane merges. And so the technology may be deployed at a certain location. So it's typically a freeway context as opposed to a corridor or intersection context. But usually, for instance, in Minnesota, we saw that the DOT in Minnesota, once they were able to show that it was working and functioning in their area, they then could deploy it across the region. And so looking at so from that standpoint, that those types of projects do tend to have a regional impact, even if it's kind of piece by piece, you're kind of applying the same technology across the region. But I think Jorge may have other non-research based examples of regional operations.
Yeah, so we've been lucky to work with Metroplan Orlando here in Central Florida. They are really big into data, and they've let us play with some pretty awesome data sets that kind of get at, I would call it planning level operations over an entire city or an entire county or region. So when you have a single corridor to work with, you can definitely spend a lot more attention. You can collect data on turning movements and intersections, queuing conditions, a bunch of other things that at a city scale just would be pretty much impossible. But working with cell phone location data, connected vehicle data, fleet data, you can start getting some of the bigger picture findings, for example, congestion or travel time reliability at a much bigger scale, looking at an entire city at once. So those are becoming more doable. I think the state of the practice still pretty much intersection or corridor level, but as the data availability keeps growing, those citywide projects are going to become more cost effective.
Great, thank you both. Staying on this topic, I am just going to give some questions and answers that some people had. So one person asked, For using these simulations, how much, and this is in reference to some of the slides Jorge had brought up, how much did Kittelson expect you to already know and how much was on the job learning? Jorge just answered this in our questions box, but there is no expectation for entry-level hires to know a software like BISIM or similar tools, so we're happy to train. I would just add on top of that, one of the core values here is also being a self-starter. And while we do want to train people and give them guidance, one of the things that I have appreciated here is that you're given a chance to sit down and figure it out yourself. We want to give people the opportunity to find methodologies and approaches that work best for them. And then from there, go back and double check with somebody else to make sure that you didn't miss anything. So I would just emphasize, like, yes, we will train you, but we won't micromanage you. I know that for me, that's really important. Shannon or Jorge, anything else to add on that?
Thank you. Got it.
Great. And then somebody else asked what software was being used for the queue jump simulation Jorge showed in his presentation. And he said that we used an open source simulation engine, Sumo. All right, so with that, I'll switch back over to some of the other questions from the form that we got earlier. One question that we got was, how can low-income communities use trackers to monitor vehicle, bicycle, and pedestrian flow? I think this is a great question and glad that somebody brought it up. Let's maybe start with Jorge on this one and then go over to Shannon for any thoughts on that.
Yeah, so I remember reading that question, and maybe the person that asked is here on the call and could clarify, but there are some technologies out there that let us count pedestrians, vehicles in an automated fashion without necessarily tracking the individual person all over the place, right? We do have to have a lot of privacy safeguards and considerations when we collect this kind of data. But there are some sensors out there where we could place it on a trail, for example, and at the end of the day, we will know 100 people walked by here.
Yeah, and I'll answer to so there are a number of methodologies or ways that governments can use to count. And so Jorge mentioned, there's a program in North Carolina where the North Carolina State University for North Carolina Department of Transportation launched exactly like 70 to 100 of these permanent count stations for pedestrians and bicyclists specifically. And so at that point, it was the team's role to make sure that they were representatively capturing data across different factors, including income level and community status. Another consideration to this question is that oftentimes data that is available, like before smartphones, there was TomTom, and so TomTom would provide that data to transportation officials for a fee. And so one way that this was sometimes structured was that the state DOT would purchase data for the statewide. And so the funding structures get a little bit tricky, but sometimes it's not solely on the budget of the community or the local city or municipality to fund these sort of data collection efforts. Oftentimes that funding comes from a regional group or from a statewide group. And so it's really dependent on what state you're in and what region you're in. But there are also opportunities to use these larger data sets. And of course now with bike share, some cities for the dockless bikes, in order to be permitted to work in the city, those companies have to turn over some certain types or amount of data so that the cities can use that. So I would say that there's increasing abilities for communities to collect data, and the specific methods just kind of depend on their circumstances.
Yeah, great. Thank you, Shannon and Jorge. I would also say to the person who asked this question or anybody interested by this question, I'd highly recommend going on to Kittelson's website and checking out the Baltimore dockless bike article that was written by Ethan Hasiuk. I read this a while ago and it was really fascinating for me. Basically, he had been working with the city of Baltimore in-house and had some information from some dockless mobility programs that they're working with, where they were basically looking at tracking low-income communities and use of those sort of micro mobility measures. It's a really great article. I would highly recommend you check it out. All right, so with that, I think we've got about 10 minutes left, and there are still a number of questions that pertain a little bit more generally to why we chose transportation operations as sort of an area to focus on. So with that, I'll move on to this question that we got from our form before the webinar. What have you found particularly fulfilling in your respective careers as transportation operations professionals? I think we'll do Jorge on this one, or actually, no, let's do Shannon first and then Jorge. I've been trying to switch back and forth.
Okay, sure. So I have really found a lot of enjoyment out of getting to spend a long portion of my career working in one area. So I started as a graduate student working on diverging diamond interchanges, and I looked at them in the context of operations as well as design and safety. So the projects that I've worked on throughout my career have evolved. It hasn't been one consistent project. But being able to work in that area over a long period of time while also doing other work on the side has just been really enjoyable to build that knowledge base, to become a leader in that area, and to have been able to spend a lot of time working and focusing on diverging diamond interchanges. It was just, nice to look back and recall all the things that I have learned and really get a lot of personal satisfaction from being able to kind of quantify that knowledge gained over my career.
Great, thank you, Shannon. So my experience with traffic ops, the one project that I found really satisfying on a personal level was working in the San Francisco Bay Area, turning on RAM metering at 2 or 3 major freeways, just kind of outside the San Francisco core. And what I found rewarding about that project was that I was the main analyst from beginning to end. So we would come in and design the kind of ramp layouts where the ramp meters would go. We would then go and figure out, based on existing conditions, again, existing conditions analysis and the prevalent traffic patterns, what the metering rates need to be so that it's kind of at that optimum point where the freeway is doing great, but you're not creating some big queues that are backing up onto the arterials. After that, we would basically program the little ramp metering controllers with the timing plans that we came up with, and also go out in the field the day that they're turning them on and drive up and down those freeways, pausing at the on-ramps and seeing the queues build up and people using it for the first time. And a few months later, we're back at the office trying to sort out the travel time savings or increases that resulted from the RAM metering, and then telling the story to our client. This is what happened, and from beginning to end, seeing that come to life and seeing how we can, we did most times get some pretty big travel time savings with very little capital. So this is not widening anything. This is just having that operational strategy that can squeeze out just that tiny bit of capacity in the peak hour and save a lot of people a lot of travel time. So that was pretty rewarding.
Yeah, and I'll echo that one of the benefits of operations is there's not always, but oftentimes the projects are implemented almost literally with a flip of a switch. And so you don't always get to be there when it's flipped, but it's the times that you do, it can be very, very rewarding.
Yeah, I will say, when this question was asked, it made me think of one where I was basically there when the switch was flipped. I'll just kind of deviate a little bit and share a little bit on that project. But I had worked on a project in Alexandria, Virginia a while back where we were trying to reduce the number of vehicle travel lanes to provide bicycle lanes. So I think one thing that I really loved about Shannon and Jorge's presentation is that I think sometimes people get the conception that traffic operations is just about the vehicular mode, but it's not. That's why Shannon was showing you the different analytical tools for pedestrians and bicycles that you can use at alternative intersections. So in this case, we were trying to figure out what's the signal timing that you need to do along the corridor if you're going to repurpose that travel lane into a bike lane. And it was a very contentious project. It really drove a wedge for some members of the community. And through the community outreach process, it became really obvious that the people who were the most vulnerable community members, children, disabled residents, minority communities, would really benefit from the addition of the bike lanes and the better pedestrian and bicycle facilities. So we just barely got the bike lanes approved. They had to go straight out and repave the road and redo the signals and, get everything up in pretty much a month after we got the okay from City Hall. And I happened to be driving through the intersection after they had made the changes. And I was sitting there, I was checking the vehicle cues, like, okay, did the model turn out right? Like, how ground truthed was it? Was everything coming out to be pretty accurate? And those cues were clearing after every signal cycle, and it felt great. And then my heart just soared when I saw, a young person riding in the bike lane that I helped work on. So it's really satisfying to be there and to see what you thought would happen actually happen and see how it can benefit people. So just wanted to share that little example. All right. Kind of along that same line, somebody asked, what kind of education should I pursue to do this kind of work? So now that you know how fulfilling it is to do this work, Shannon and Jorge, I'd love to hear your suggestions for how people can set themselves up to do this kind of work. Let's start with Jorge and then do Shannon.
Sure. So I'll first speak to what's most common. So a lot of people at Kittelson that work and at other consulting firms that work in traffic ops are coming from a civil engineering background, as I am as well. I did civil engineering in undergrad and I did transportation engineering for a master's, and that really helped me dive in a little more into transportation, actually a lot more, because in undergrad, at least where I went to school at UF, they basically make you take classes in all the civil engineering tracks, geotech, structures, construction. And so you get very little exposure to transportation, especially traffic ops. A lot of the time is spent on design. So having that master's really gave me a much better understanding of the concepts behind freeway operations, behind how a traffic signal works. So that's what I find is the most common background for this kind of work. But I'm looking forward as the profession evolves that people from other backgrounds can start doing more of this work. We've got some staff that have backgrounds in mathematics or urban planning that have gotten interested in getting into the weeds of traffic operations, and they're able to do this work just as well. So just because most people are doing civil engineering doesn't mean that that's what you got to do. There's definitely other ways to gain this background knowledge.
Oh, Shannon, you're on mute. Sorry, I was typing away answering a few questions, so I muted myself to avoid. Personally, I have, similar to Jorge, I have a bachelor's degree in civil engineering with a focus in structures. My undergrad didn't have a transportation program. And then I did a master's in transportation, which for research is important to have the master's, less so in transportation, a PhD. But I would say for people who are interested in working, there's no reason why you should feel like you have to go and get a master's. It's very well recognized as, you know, we all, it's a small community. We all know kind of what the programs are and what you learn. And so in undergrad, if you're interested in transportation, you know, get an internship with a transportation firm, and that will teach you a ton. I don't think anyone expects someone to come in out of undergrad with a ton of knowledge in transportation. And so, you know, I wouldn't be too concerned about that. But as Jorge mentioned, there are folks that come into transportation outside of the civil engineering field entirely. So I think we even have somebody who has a background in public health that works for us. So there are some less conventional education backgrounds.
Well, great. Perfect timing on that too, Shannon. We have a couple of outstanding questions, but I think we've answered really most of the ones that all kind of coalesced around similar themes. So I guess we'll just go ahead and wrap up for the evening. You know, I'd just like to say thank you all so much for attending and participating. As I said earlier, you should be receiving a follow-up email with today's recording and links to RSVP for the other sessions in our series in case those might interest you. And if you would like to learn more about Kittelson or express interest in working with us, please visit our website at www.kittelson, it's ELSON.com. And I hope you have a great evening. Thanks again for joining us. And thank you again to Shannon and Jorge.
Have a good night.
Yeah. Good job, Amelia.
Take care.
Bye-bye,
Bye-bye.
everybody.